Myself, Surendran, Chief Autonomous Officer at Maxpay Technologies. So in today's session, we are going to see about autonomous mobile robots, which will help for the Kanban systems and the manufacturing in the manufacturing industries. I'll quickly start with the introduction to AMRs. I think the robots have been into the market for almost about 30 years, but still manufacturers or they not completely transformed autonomous factories to increase the safety and productivity. And there are a lot of more opportunities for robotization. So why still there are scope for improving the autonomous systems in the manufacturing industries and completely turning the manufacturing industries into autonomous factory. There are various use cases in which the automation system can be enabled with the help of AMRs and robots. So one such of use cases have been listed down here. One is like kind of a safety inspector robot, inspection robot for quality inspection, cleaning robot, autonomous forklift, and for material movements, tool carrier robots, and even for robots for the maintenance team. So there are a lot of many more opportunities for the automation and usage of AMRs inside the factories, and specifically for the material movement and the cleaning purposes, so that the complete factories or complete material movement, which includes a lot, which involves a lot of manual efforts and also puts worker safety also into consideration, can completely be automated with help of this kind of AMRs. So this is the quick study on how the market has increased or how the adoption of robots and AMRs have increased over the past few years. So if you can see, there's a clear trend of increase by over 46% compared to the last 3 years, from 2018 to 2021. Almost the use of conventional robotics has increased much more in the manufacturing segments. And also usage of AMRs and AGVs have also seen a significant amount of rise by almost 22% from 2018 to 2021. So this report clearly indicates that the usage of AMRs has been now globally started being adapted by various manufacturing industries for various use cases. And also Gartner released the priority matrix and technology wise. So if you can see, AMRs is now featuring for the next 5 to 10 years. It is considered as a mainstream adoption for the transformation, digital transformation journey for over the next 5 to 10 years. So people are talking about Industry 4.0 on the digitization, digital transformation. So now AMRs will play a very crucial role in converting the complete autonomous factories, lights off factories, and many more autonomous use cases as well inside the factories. So this slide shows about how AMR plays a very crucial role in the lean manufacturing. So if you can see lean manufacturing, there are these a couple of two concepts in lean manufacturing. One is just in time and Kanban. So there are multiple areas apart from AMRs like cloud, additive manufacturing, augmented reality, big data analytics. So in case of AMRs, there are a couple of major use cases like flexibility due to production changes, and have been considered as one of the major use cases for AMRs to have the just-in-time 4.0 concept, and minimization of human errors and automated logistics. So this automated logistics also can be integrated with our ERP or any other enterprise application system, so that the triggering of this autonomous material movements can automatically be initiated based on the planning and scheduling. Similarly, for the Kanban Kanban systems, the AMRs also play a very crucial role in controlling the material movements between the assembly stations and ensuring the right amount of materials available at the right station at the right time. So this is one of a couple of key use cases for AMRs in the lean manufacturing concepts as well. How this AMRs has been evolved. So this tree, it's kind of a tree diagram that clearly shows how the AMRs have been categorized, or AGVs or the autonomous robots have been categorized based on their material movement as well. So for based on industrial application and the mobile platform, it has been categorized. So and for navigation type, it can be either autonomous mobile robot or automatic guided vehicle. So automatic guided vehicle comes into the concept when there is a separate magnetic rails are required for the movement of the vehicle. So it has to have a guided path for the vehicle to move it, while autonomous mobile robot completely moves upon the navigation based purposes. So it can have it can be in the form of a small AMRs which can carry up to 50-kilogram load to an BOPT, that is battery operated per truck vehicle, which can carry about 2 ton to 5 ton weight of load. So it doesn't require any magnetic strip or any guided path for that vehicle to move it. Rather than it uses the navigation systems which will help the robots to automatically map the complete manufacturing floor and then find its own path according to the obstacles being directed there. So apart from this AMRs and AGVs, there are industrial robots and the mobile industrial robots that can be used for multiple use cases like robots and cobots for automated material loading and unloading into the machines and also lifting of heavy materials inside the factories. So this is a classification of robots according to ANSI RAA standards. And this slide talks about the major differences between an AMR versus AGV, because earlier, maybe before introduction of AMRs, AGVs has been widely used, but there are some disadvantages in AGVs where it requires a track to follow it. If the track is again modified or damaged, the entire track has to be relayed for the guided vehicle to follow the same path. And if there is any obstacle, it will stop it. And also, if we wanted to use the same AG for a different route, then we need to again remap it. It is very difficult to again remap it and lay the complete strip along that map, and the AGV has to be followed the same path. And it requires the depots for AGVs to store and then it move it forward. And it does not deliver to the user location; it delivers to along the path and it travels to the dedicated areas and difficult to expand. So these are some of the disadvantages that we have seen in AGVs, whereas AMRs has the comparatively and good benefits compared to the AGVs, where it will use a completely trackless navigation. It uses maybe lidar-based technologies in order to completely map the shop floor, and then it can able to stop the vehicle, or it can also able to go around the obstacle if any obstacle is detected, so that it can able to find the best optimum path to reach the final destination. And it can be easily be remapped as users need to select only the start and end location for the AMRs to move. So automatically it will find the best path to move inside the factory and then it will start moving it. And then it delivers to the user location, travels around the people, and it's very easy to expand as well. So these are some of the reasons why we specifically go for AMRs in the manufacturing industries. And there are various form factors it can adapt, like it can either pull or it can either carry or it can either lift. So there are several form factors for AMRs where the truck is able to pull the payloads or most kind of this where it can able to attach to the vehicle and can able to pull the cart or lift a small amount of material, and forklifts are used to lift the heavy materials. So these are some of the form factors that it can be that take place. AMRs can be used in for various these things. So according to our use cases, there are multiple AMRs that can be configured based upon the payloads. So trolleys are something which can be used for 0 to 100 kilograms of payload, and A500 is something which can be used for up to 500 kilograms of payload. And tuggers can be converted autonomous tuggers can be used up to 1,500, and BOPT is something which can lift up to 2,000 or more than 2,000 kilograms of payload. So these are some of the various use cases that AMRs can be configured. So based upon the payload and also based upon the runtime and also what is the current requirement for that particular use case, the required vehicles can be selected and can be easily configured map inside the factory. And it has the various autonomous features as well. So as I said, it completely works on what is it, pathless navigation, where it will use the lidar-based technology to completely map the entire floor, and it will also help to find the best path using the mapping system. And it has the required sound and alarms and buzzer systems so that the usage of the indication can be given to the AMRs. and complete load carrying mechanism can be automated, and the vision system for 3D depth camera so that easily to identify the which material has to be picked up, and also the required safety sensors. Likewise, to detect the obstacle, 360-degree safety detection is also as possible, and the required emergency stop button is available so the vehicle can be stopped in case of any emergencies. And the complete remote monitoring system of the vehicles can be enabled so that the vehicle can be completely monitored from a remote location as well. And also the fleet management system is enabled where multiple AMRs can run in a single shop floor, and then all the AMRs can easily be tracked and monitored with the help of the fleet management system. So these are some of the major features for the AMRs. And significant applications like there are, as I said, right, there are multiple forms it can take in, like AMRs with conveyors can be used so that it can go and fit into assembly line, and then double laid conveyor or pallet transport or lifting mechanism or tugging mechanism. So likewise different application, different forms the AMRs can be used for various applications like industrial logistics, warehouse management, and also for e-commerce fulfillment, defense applications, healthcare applications. So these are some of the major applications where AMRs can be used. And this is again emphasizing on the application part where in healthcare where a lot of small material movement, quick material movement is required between the maybe we can say the nurse stations and to the patient area, like clinical goods, meals and materials. So this AMRs can help in that autonomous movement. And similarly in manufacturing industries where raw material has to be keep on continuously moved from one place to another place, say for example from warehouse to the assembly line or the machining area, and then from machining area to the packing area, from packing area to dispatch area. So all this complete material movement can easily be automated, and also the wait time for the people to wait in that assembly stations for a raw material can easily be avoided because it is not completely manual, it is completely automated. So based on the request from that particular station, the AMRs will go to the particular material area and it will pick up the material and it will dispatch to the required station. So it's very not easy to configure, and also it eliminates a completely manual dependency so that the required materials is taken at the right place to the right at the right time to the right place. And other use cases like hospitalities in the hotels and this thing, AMRs can be used in retail and also the warehousing where the bulk material movement is required. So these are some of the significant applications where AMRs can effectively be used. And also this Kanban system is one of the key concept used in the manufacturing industries. Like earlier they were using paper-based Kanban, which is most of like a pull mechanism where the materials will be given to each assembly line, and once it is done, then it will be pulled to the next station. Likewise, the material movement is also completely manual there. So how this Kanban system can be replaced with the e-Kanban system is something now is being adapted by the industries also. The normal manual Kanban system, it require a high manpower, and there is delayed the data being transferred, and lost and wrongly processed cards is one of the key problems there. And then inventory size is not managed properly. The lead times is much longer. So these disadvantages or these limitations can be overcome by the e-Kanban system, where the complete Kanban system is automated because there is low manpower required, and the real-time visibility of the parts can easily be tracked, and errors can be easily eliminated, and right size of inventory can also be maintained. Lead time can be easily reduced. So this is something a visualization of how the Kanban system can be integrated with our AMRs. So if you can see is from station 1 to station 2 based on the lead time and also based on the cycle time of that particular production part, the vehicles will start moving between the stations. So the material will be located or given to the right station at the right time. And also this is integrated with our IoT systems, so that any trigger from that IoT system, like which machine should run which part should run on which machine on what time, that scheduling will be triggered from the IoT system, and that system will be giving input to the AMRs in order to move approximately or to move appropriately inside the manufacturing area. So this is a major advantage of integrating this AMRs with our IoT system, so the complete end-to-end process can easily be automated with very less manual effort. So the coming next 2 to 3 slides speaks about the major industrial applications. There are three areas we are particularly talking about. One is for the machine shop, where the material movement has to be done between one machine to the another machine. So for that, we can able to use the AMRs, either BOPTs or tuggers, in order to locate the particular material and to deliver to a particular station. So the triggers can be used by given by help of a push buttons or a user interface, so that they can just request for the particular material, and the AMRs will start moving and start delivering, start to deliver the particular materials in that particular station. It is very much ideal for the shop floors where the components are machined based on the process sequence, so that the material movement can material delivery can much more faster. And also it can be either configured in a fixed path, or it also can be configured on the different varying path also based upon the obstacles that is being created on the shop floors. So this is one of the key area of the usage of AMRs in the machine shop. Similarly, for the assembly lines, where the movement of the finished and semi-finished goods between the stations is one of the key areas also, which is seen in the as a wastage of time, because people will be waiting on the next station for the material to arrive. So how that material movement can seamlessly being configured is one of the key use cases where this AMRs can be used. And also the continuous movement between 2 points, uh, as long as the available pallets in that area is one of that is, if there is any pallet based material, so the pallets can material can be based on that particular pallet, and the BOPTs can deliver that particular materials to that particular station as well. And it also we worked on a fixed path or variable path based on the requirement, and the triggers can be done with help of the job card based mechanism, or also the pull card based trigger also can be done, or or push button based or HMI user interface based trigger also can be initiated for the industrial applications. The third major use case where it finds a very good very good usage is the movement of material between the departments. Stay from warehouse to machine area, from machine to testing area, from testing to logistics to finished good area, finished good to dispatch. So these are the complete set of material movements between various departments. So these movements can easily be automated with help of this AMR, so that they can deliver the materials in a fixed path, and also it can deliver at the correct time. So these are some of the major industrial use cases where AMRs is now being more commonly used. So this is some of the benefits and why the reasons that we need to adapt. So this is one of the use case study done in an US factory where labor cost is much higher. So how 5 shifts for 5 days or 2 shifts they spend almost spending $87. That contributes around 20 to 30% of the annual salary. So that can easily be automated with help of this AMR. So labor cost is one of the major reasons to adapt to AMRs. And the next significant reason is the worker safety there, because a lot of workers incidents are happening inside the industry while the workers are lifting heavy materials. So if you can see, the average cost of the fall is around $46,000 per year, and also around the average cost of strain is around $33,000. So these are some of the areas where the manual usage, material movement can easily be eliminated, and the AMRs can be used so that the worker safety can easily be ensured. And also, to in order to have the overall efficiency and speed, this material handling is one of the key areas. Where we require a faster lead time and higher productivity, so the AMRs is the best solution for them to use it. So this is one of the key areas, key reasons why we need to adapt to the AMRs as well. And these are some of the drivers, as I said, right? The speed, the cost, and also the latest technologies can be increased, and also how the safety of the safety and well-being of the employees can be ensured, or some of the key drivers where we go for the AMRs. And these are some of the major benefits for using of AMRs, like it is very safe to operate, and it is very flexible. It can be easily now moved to different lines or different departments based upon the need, and it is highly dependable because it can run for once it is charged, it can the AMRs can easily run for 6 to 8 hours of shift, and also it is easily chargeable. Just a plug point is required to charge at the AMR. So whenever it's not used, it can be put on charge, and it's very easy to install. and it is for built for multiple use cases and flexible use cases as well. So these are some of the key benefits of using the AMRs. So, what are the critical parameters to start with the AMRs is something like first we should identify of all, first we should know what is our requirement like in case of load, how much load we are going to carry, and what is the robustness that we are trying to expecting from this AMRs, like whether it is has to run for 5 hours or 8 hours or 10 hours, and if there is any other external systems that is to be integrated. So these are some of the key critical things that we should able to keep in mind while going for the AMR. Also, what kind of benefit that we are going to realize from using this AMRs, and which environment we are going to operate, whether it is indoor or outdoor, or if the surface contains any ramps or it has very uneven surfaces. So that also should be considered. And what kind of users is going to use this one, whether operators or any untrained operators are going to use it. So these are some of the key things that we need to note it while going for any selection of the AMRs. And the next three slides shows a couple of use cases for which we have demonstrated for the autonomous navigation. So this is one of the use cases where the material movement can easily be automated. If a worker is working in an assembly station and immediately requires some of the spare parts movement, so it can easily be transferred from the store to the particular station with the help of the AMRs. So this is one such AMR where it is used for the tools and spares carrying. So if you can see the complete map is being mapped here, and the users can select the end location, and the vehicle will start moving by automatically taking the particular path. It doesn't require any strips or any guides in order to move. So it will automatically start moving by carrying the particular material. And the speed of the vehicle is also fully configurable. So as per the standards, it can run up to 5 meters per second. So that is the maximum speed allowed as per the standards based upon the load, obviously. If it is carrying heavy load, I think 1.9 to 2 meter per second is the allowed range. And all the safety detection or safety equipment is being enabled so that if any obstacle is detected, the vehicle will stop or it will try to find an alternative path so that it can able to move. So this is one such use case for an material movement. And this is the automated movement of the trolleys. So it is mainly used for payload of up to 50 kgs to 100 kgs, where it can able to go between multiple stations there. So if you can see, it is completely moving inside the required racks, and it can able to stop there and then able to get the required material, and then it will move to the next station. It will automatically have the alarm systems so that once the vehicle has reached a particular station, it will give an alert to the users so that they can unload the material and load the next material to the next station. So here they're selecting to the next station. Once it comes to one station, either it can select to the home position or it will move to the next station. This is one such use case for small material handling. And this is something which is mainly used for the heavy material handling. Like this is a battery operated pallet truck vehicle where it is used to lift an heavy material of around 1 ton or 2 ton or 5 ton capacity. So the navigation or the movement is completely autonomous. Just start and end location, and you can also select the path, the fixed path it has to move. So it will always move to the same path. So it will stop if there is any obstacle is being detected there. The range of the obstacle detection can also be configured, whether it is 9 meters or 5 meters of can easily be configured there, so that it can able to take the obstacle within that particular range to stop. It has 360-degree obstacle detection. So either sideways or backways or anywhere, the obstacle is being detected. It has the emergency stop button. So in case of any emergency, it can be easily stopped. The operation can be resumed again once reaching the system. Reverse safety camera is enabled there. And also it will detect the pallet with the help of the QR code. So that QR code will be restricted on each and every pallet. So the same thing will use to identify as well as align the BOPTs accordingly. So it will detect that particular load, the particular pallet, and it will lift the particular pallet and deliver to the required place. The batteries can be easily be removed.